Okay, number one, graph the compound inequality. First thing we want to look at is here we want to see that we have a closed circle because it is equal to, and over here we have an open circle. So we're going to put a closed circle at -4, and an open circle at +6, and then we are going to draw a line connecting the two pieces. So this would represent -4 is less than or equal to x, so x is all of the values between, and 6 is here. Number two, graph the compound inequality. We are going to do the same thing. So at -2, we have a closed circle, and at +3, we also have a closed circle because they're both equal to. They're less than or equal to. And then we draw a line connecting the points. Number three, solve for x, graph the solution on the number line. Okay, so solve for x, that's the first thing that we have to do. So we need to get x all by itself. So we need to remove that 6 and that -3 being multiplied by x. We'll start by moving the 6 to the other side, and we are left with -3x is less than or equal to 12. Okay, and then we are going to divide everything by -3. And when we divide by a -3, when we're dealing with inequalities, we need to take the inequality symbol and we need to flip it around and make it the opposite. So we end up with x is greater than or equal to -4. So we're going to put a closed circle above -4 because it's equal to. And it says the values of x are greater than that, so we move in that direction to show greater numbers. Okay, number 4, solve for x, graph the solution on the number line. So first we need to solve for x, so we need to get x by itself. And we will move the 4 first. And we're left with 2x is less than 8. Divide everything by 2. And we end up with x is less than 4. So we're going to put an open circle above the 4, and all the values of x are less than that, so we draw an arrow moving in that direction. Okay, number 5. You want to buy a pair of pants from the tailor, and you can spend at most $75. You have a coupon for $10 off any item in the store. Write an inequality that you could use to find the original price P of the pants you buy. Okay, so the total amount that I want to spend is $75. I notice that I also have a coupon for $10, and we want to call the original price of the pants P. So when I go to write this, I know that I can take the price of the pants minus the $10 coupon, right? And at most, I can spend $75. So if I was going to set up an inequality for this, I'm looking at how much do I want to spend. I want the price of the pants minus the $10 to be less than or equal to $75. I can't spend more than that, so this side is how much I spend, and this would be the total. Okay, number 6, you want to buy a candy bar and you can spend at most 65 cents. You have a coupon for 25 cents off any item in the store. Write an inequality that you could use to find the original price P of the candy you buy. Okay, same thing. We have the price of a candy bar, and we have a coupon for 25 cents off. So we would say the price of the candy bar minus the 25 cents has to be less than or equal to 65 cents. If I don't have more than 65 cents, I only have the 65 cents, I can't spend any more than that. So what I spend has to be less than 65 cents. Okay, you have 2 summer jobs as a landscaper. You earn $10 per hour mowing lawns and $20 per hour planting trees. Let X represent the amount of time and hours you mow lawns each week, and let Y represent the amount of time and hours you plant trees each week. Your goal is to earn at least $500 per week. Write an inequality to represent the situation. Okay, so for this week, I can earn $10 per hour mowing lawns and $20 per hour planting trees. So to represent that, we're going to do $10 per hour for mowing lawns, so 10 times X, plus $20, let's fix that, plus $20 for planting trees, so 20Y. And I want to earn more than $500. So this represents my earnings, what I can earn. So I want to earn more than or equal to, because it says at least, $500 per week. So once again, we're looking at how much we earn. It needs to be at least $500, so we can earn that much. It's equal to 500 or more than that if it's at least. Okay, number 8. You babysit for 2 families. You earn $6 per hour babysitting for the Winter family and $8 per hour babysitting for the Rogers family. Let X represent the amount of time and hours you babysit for the Winter family each month, and let Y represent the amount of time and hours you babysit for the Rogers family each month. Your goal is to earn at least $250 per month. Write an inequality to represent this situation. Okay, so I want to earn at least $250 per month. That means I could earn that much or more. Okay, so to write what we would earn, it's $6 per hour for the Winter family. They said to use X for the time for the Winter family, plus 8Y for the Rogers family. And now we want our earnings to be at least $250. So that would be equal. And then if we want more than that, we would say it's greater. So the earnings are greater than or equal to $250. Okay, number 9. Sketch the graph for that inequality. So in order to sketch that graph, we need to put it into slope-intercept form. So I'm going to rewrite the problem here. And I am going to isolate the variable y, so I want to get y all by itself, so I will add 2 x's to both sides so that it will cancel out here. Okay, then I'm left with 3y is greater than or equal to 2x minus 9. And I still need to get rid of that 3 in front of the y, so we are going to divide by 3. And 3's become 1, so 1y is greater than or equal to 2/3 x minus 3. Okay, so the negative 3 or the minus 3 represents our y-intercept. So I'm going to start at negative 3. Put a dot here. And we're going to follow the slope. It says to go up 2 and over 3. So up 2 over 3 would be here. And if I had more space, I could put more dots or more points, but I don't. Before I draw my line, I notice that it is equal to, so it will be a solid line. So I'm going to draw a solid line. And the values of y are greater, so we're looking at the shaded area above the line. Okay, number 10, sketch the graph for y is less than negative 3x plus 4. This one's already in slope-intercept form, so all I need to do is put the points on the graph. So we are going to start at positive 4 on the y-intercept. And from there, we have a negative slope of negative 3 over 1, so we're going to go down 3 units and over 1. And then we will do that again. And if I had more space, I would do it again. And we see that it is less than but not equal to. So I will draw a dotted line or a dashed line. And the values of y are less than the line, so we are going to shade under the line, so everything below the line. Number 11, solve the system. You could solve this by elimination. So if you use elimination, we would eliminate the y's and solve for x. Or the other way that we've been using in class recently is solving for y on both of them. So putting all of them into y equals into slope-intercept form, and then going into the calculator and going second trace 5, and then we're trying to find the intersection point of the two lines. So when it says solve the system, we're just looking for that intersection point where those two lines cross. So we could graph them by hand, we could put them in the calculator, let it find the intersection point, or we could use elimination and eliminate one of the variables, solve for x, substitute that back in, and then get the value for y. So I'm going to set these equations up. 5x plus 4y equals negative 12. And we're going to set them up into y equals. So I'm going to subtract 5x from both sides. And divide everything by 4. And I'm left with y equals negative 5/4 x minus 3. So there's one equation in slope-intercept form. I would also do the same thing for the second equation. Do that one in red, so we have 3x minus 4y equals 20. We're going to move the x's. And divide everything by negative 4. I'm left with y equals 3/4 x minus 5. Okay, so if you're using your calculator at home, or if you're using the one that's on the free one from the computer, you would go to y equals, type in this equation in the first and y1, and then you would type this equation in for y2. Once you have both equations typed in, you push second trace 5, and then you will, once the line's graph, you hit enter 3 times, and it will give you the intersection point, the x and y value. So the x and y value would be 1 comma negative 4.25. And if you did it by hand, you would also get the same answer. But if you want to check it, type it in the calculator. Make sure you get the same point. Okay, for number 12, we are going to solve the system again. So we are going to find the intersection point of these two lines. I will set the first one up and solve for y. So we need to move the x to the other side. I'm left with negative 3y equals negative x plus 8. And divide everything by negative 3. And we get y equals 1/3 x minus 8/3. And we will look at the second equation. I will use black for that. Is x plus 2y equals 2. And we also need to put that into y equals. So we'll move x to both, or we'll add negative x to both sides. And divide everything by 2. And we get y equals negative 1/2 x plus 1. Okay, we would follow the same steps as we did on the problem before. We will type this equation into y1, and well, first we'd push y equals on the calculator. We would type this in for y1. We would type this equation in for y2. Once you have those two equations in, you push second trace 5, and when the calculator graphs the lines, you will push enter 3 times, and at the bottom it'll say intersection. It will give you the point x is 4.4, and the value of y is negative 1.2. Okay, so that would be where the two lines cross, or is at that point. Okay, number 13, find the point of intersection. Okay, so we are going to do the same thing. We can see that one of them is already in y equals. So if you're doing it a different, or if you're using one of the other three methods, there's three methods total. So if you're going to use a different one, you would use substitution here. So we would substitute x minus 4 in for y, and then that would eliminate the y's, and we would solve for x. Then you would substitute it back in to find the value of y. But we're just going to put this one into y equals as well. So we're going to take this top equation and we will change it to slope-intercept form, or y equals. Okay, we'll move the x's. Divide everything by 2. And we get y equals negative 3/2 x plus 17 divided by 2. Now I could change that to a decimal, but I'm just going to leave it as a fraction because I can type that in the calculator as well. So now I have two equations in slope-intercept form. I have this one, and I have this one changed to this. So I will type these two in my calculator. Okay, so we'll follow the same button sequence. We will go to y equals. We will type in equation 1. And in the second line, we will type in equation 2. Second trace 5. When the lines graph, enter, enter, enter. So we hit enter 3 times, and it will give us the intersection point of 5, 1. And that's where the two lines intersect, or that's where they cross, or that's the solution for the system. Just different ways to say that. Okay, number 14, use any method to solve the system. The two easiest ways, you could use substitution, where you just make this equal to this, and then you would solve for x, get that answer, plug it back in, and get your answer for y. Or you can use your calculator, and you can go into y equals, type in both of the equations, and when you do that, you go second trace 5, and enter, 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 and it will give you the intersection point of 1, 8. So that's the point where the two lines cross, or we would say that's the solution to the system, or that's the intersection point. Okay, number 15. The Oak Ridge High School Drama Department is putting on a performance of The Music Man. The auditorium holds 480 people. They are planning to charge $15 for adult tickets, A, and $7 for student tickets, S. Assume the show is sold out. Write a system of equations that can be used to determine the number of adult tickets sold when they made $4,320. Okay, they're not asking us to solve anything. It just says write a system. Okay, so I have to look, if it's a system, I have to look for information that's going to give me two equations. So the first equation comes from the number of people that are at the show. So it says the auditorium holds 480 people. That could be adults or it could be students. We don't know which ones or how many of each. So what I'm going to write is the number of adults, A, plus the number of students, S, equals 480. So some number of adults plus some number of students combined is going to equal 480. So that's the first equation. Okay, now for the second equation, we can see that they're charging us $15 for adults and then $7 for students. With the combination of adult tickets and student tickets sold for those prices, together it made $4,320. So we're going to take the money times each adult ticket, so $15 per adult plus $7 per student equals the 4,320. So we have 15A plus 7S equals 4,320. Okay, so we're looking at number of tickets plus number of tickets equals total number of tickets, and the value of the adult tickets plus the value of the student tickets that were sold equaled 4,320. So we have money, 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 ticket, ticket, ticket. Okay, 16. The Oak Ridge High School football stadium holds 1,200 people. The charge is $6 for adult tickets, A, and $3 for student tickets, S. Write a system of equations that can be used to determine the number of adult tickets sold when they made $4,200. Okay, this is the exact same type of problem. We have tickets being sold. We have a total number of people. They are adults and they're students. So we have the adults plus the students equaled 1,200 people. So we have people plus people equals more people. Now we have the price for the tickets. So it was $6. So we have $6 per adult plus $3 per student equaled $4,200. Right? So in this we had money plus money equals more or equals money. So we have money, 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 tickets, 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 or people, people, people. This gives us a value of however many adults went for $6 per ticket. This gives us the value of however many students went to the game times $3 per ticket, and together those values equals $4,200. 17. Delvin buys 5 bananas and 7 apples for a total of $2.75. Brianna buys 4 bananas and 12 apples for $3.40. Write a system that can be used to find the individual prices of bananas and apples. Well, there's a little typo here. It's not 4 ears bananas, so that doesn't mean anything. I've already had a few students ask me what that is. That's just a typo. Alright, so now we're looking at bananas plus apples and what they were sold for. So that gives me two things together equal that as a total. And these two sets of things equaled $3.40 for a total. Okay, so we have 5 bananas plus 7 apples equal $2.75. Okay, then we also, someone else bought bananas, so they bought 4 bananas plus 12 apples, and they spent a total of $3.40. So this would be the system that we would set up, and then we would solve it by either changing them to y equals or using elimination. Number 18. Harvey buys 6 ears of yellow corn and 4 ears of white corn for a total of $6.15. Alice buys 3 ears of yellow corn and 15 ears of white corn for $8.95. Write a system that can be used to find the individual prices of the yellow ears and the white ears of corn. Okay, same type of problem, except we're just talking about different types of corn. So we have 6 ears of yellow corn, so 6 Y's for yellow corn, plus 4 ears of white corn for a total of 615. Okay, that would be our first equation in that system. Now we're going to take Alice's purchase. So she took 3 ears of yellow corn plus 15 ears of white corn, and altogether she spent $8.95. So that would be our second equation for this system. And then it just asks us to write it, so we're not going to solve this one either. Okay, 19. At the Daisy Duck Diner, they are running breakfast specials through the month of March. These are based on the combination of eggs, E, and bacon, B. In the first special, you can get 3 eggs and 2 slices of bacon for $8. The other special is 1 egg and 1 slice of bacon for $3. The specific question is, how much does 1 egg cost? So we're selling two things, or we're purchasing two things, and we're looking at eggs and bacon. They tell us eggs is E, bacon is B. So we're going to look at the two different specials. In the first special, you can get 3 eggs, so 3E, plus 2 slices of bacon, so plus 2B, and you would have to pay $8 for that combination. Okay, in the other special, we're looking at 1 egg and 1 slice of bacon for $3. So 1E plus 1 piece of bacon would cost $3. Okay, and now we just need to solve to find out what 1 egg would cost. So you could set this up as an elimination problem, or you can put it into y equals, or get one variable by itself that would represent y and put it into y equals. So I'm looking for eggs, so I'm just going to make it e equals. Okay, so that means on this first one, 3e plus 2b equals 8. I want to get e by itself, so I'm going to subtract 2b. And then I'm going to divide everything by 3. And I end up with 1 egg equals negative 2/3 b plus 8/3. Okay. And for the other one, I'm just going to move the b to the other side. So I get e equals negative b plus 3. Okay. I would type these two equations into my calculator. I would use e for my y, so it'd be like y equals. So this is going to be the same as y equals. This will be y equals. Okay, so I'm going to put y equals negative x plus 3 for the one equation. And for the second equation, it's going to be y equals negative 2/3 x plus 8/3. Okay, when I type that in the calculator, I do second trace 5, let it graph, and I find the intersection point is at 1, 2. So I'm going to write that ordered pair down. Let's do that in blue. So it's going to be 1, 2. Okay, and it said, what is the cost of 1 egg? Well, in this problem, E was the y value, so the egg is y. So that's going to be this value here. This is x, this is y. So the value of, or the cost for 1 egg is $2. So egg equals $2, 1 egg. Okay, number 20. Move this out of the way. Okay, number 20. At the movie theater, there are specials on soda and popcorn. In the first special, you can get 2 sodas and 1 popcorn for $15. The other special is 5 sodas and 2 popcorns for $35. How much does 1 soda cost? How much does 1 popcorn cost? Okay, this is going to be a system as well. We have 2 different specials here that we need to look at. Okay, so we have 2 sodas plus 1 popcorn equals $15. And we also have 5 sodas plus 2 popcorns equaled $35. So I'm going to put both of these into P equals. So I want to get P by itself here and here. So I will, on this first one, move the S's to the other side. And I get P equals negative 2S plus 15. And for this one over here, we're going to add negative 5s to both sides. And divide everything by 2. So I'm left with P equals negative 5 halves S plus 35 over 2. And it's okay to leave those as fractions. We can type them in the calculator that way. Okay, so I would type this into y equals, so it would be y equals negative 2x plus 15, and this one would be y equals negative 5 halves x plus 35 divided by 2. When I type that into y equals, I will push second trace 5, and once the two lines graph, I will look for the intersection point by hitting enter 3 times, and it will give me the intersection point of 5, 5. That means the price of each thing was $5, right? So the y was the p in this problem, right? Because this was y equals, so p equals. So this is the y, so it's $5 per popcorn, and it happened to be $5 per soda as well, because that was the x value. All right, let's look at number 21. Okay, so 21, simplify. We have 6x squared, y to the 4th, z to the 7th, in parentheses. So that's one term. That whole thing is being raised to the 0 power. Anything to the 0 power is going to be 1. So that whole piece equals 1. And in number 22, following the same rule, anything, right, it's in parentheses, so anything raised to that 0 power is equal to 1. 23, simplify. When I look at this problem, I see only multiplication here, so it's a one term times one term, so monomial times a monomial, and that is going to follow the rules of the MAD SPM. So MAD SPM. Okay, and those rules basically tell us if the operation of the terms is multiplication, we multiply the big numbers and we add the little ones. So we multiply the coefficients, and then we're going to add the exponents that have the same letter for a base. Okay, so 5 times 16 gives me 80. And then we're going to add the exponents. So we have 3 x's being multiplied times 5 x's that are being multiplied. So 3 plus 5 is 8, so x to the 8th power. And for the y's, we have 5 of them here being multiplied times 1 of them here, so that gives me 6. So y to the 6th power. 24, simplify. Okay, we're going to follow the rules for MAD SPM on this as well. Okay, so in this problem, on the I see division, so this is a fraction, so that shows me division. This is a single term up here. This is a single term at the bottom. So there's no other operation in the numerator. There's no operations in the denominator. So I will follow the rules for division. So we will divide the coefficient, or the big number, and we will subtract the little numbers, or the exponents. So 21 divided by 3 is 7. So I'm going to write 7. And r to the 5th divided by r to the 2nd, we are going to subtract the exponents, or what's really happening is 2 of these are going to cancel out with 2 of those. So we have r to the 3rd power. And for t, we have 18 on top, 14 on the bottom. So 14 of them are going to cancel with 14 out of the 18 here. And that leaves us t to the 4th power. Okay. For 25, it says simplify as well. So we will use the MAD SPM. And I'm looking at this term, the whole thing is being raised to the 3rd power. So I see that I have a power outside of a parentheses with exponents inside. So it's a power to a power. So we're going to follow the power to a power rule for exponents. So we take the big number, or the coefficient, and we raise it to that power. So it's 3 to the 3rd power. It's 3 times 3 times 3. It gives me 27. And we are going to take x to the 6th to the 3rd power. So that's like saying I have 3 groups of x to the 6th. So that would be x to the 18th. And for the last part, we have y to the 4th to the 3rd power. So that's like saying I have 3 groups of y to the 4th. So that would be y to the 12th. 26, I see 2 different operations here. I see we have multiplication, and we also have power to a power. We will do the power to a power first. It's more powerful. So we are going to, if we had any coefficients, we would take that to the 3rd power. But we don't. It's just 1 to the 3rd power, which is still 1. And then we're going to take the exponents and we will multiply them. So 2 times 3 is 6. So I'm left with x to the 5th times x to the 6th. And then I am going to follow the rules for multiplication with exponents. So we multiply the coefficients. So 1 times 1 is still 1. And we're going to add the exponents. So 5 plus 6 is 11. And we end up getting x to the 11th power. Okay, 27. In the numerator, I have a monomial times a monomial, so it's this times this. And all of that is going to be divided by this term here. And when I multiply this out, I have 8 times 1, so that leaves 8. And then c squared times c to the 4th. We're going to add the exponents there. So it's c to the 6th. And d to the 3rd times d to the 2nd is d to the 5th. We are going to add those exponents. We will then divide it by 4c to the 6th, d to the 8th. Okay, so we will follow the division rules now. So when dividing, we take the coefficients and divide them. So 8 divided by 4 is 2. And c to the 6th divided by c to the 6th is 1, because anything divided by itself is 1. Or we could see it as 6 minus 6, which gives us 0, c to the 0 power. And then we know c to the 0 power, anything to the 0 power would be 1 anyway. So we'll simplify that. So we'll do c to the 0 power. And then d to the 5th divided by d to the 8th. We subtract those exponents and we would end up with d to the negative 3rd. Now we don't want to have negative exponents and we don't want to have 0 as an exponent, so we will simplify that. And I'm left with 2 times 1, because c to the 1st is 1. And then d to the negative 3rd drops to the bottom and becomes a positive. So when we multiply that out, 2 times 1 is 2. And we have d to the 3rd on the bottom. Okay, number 28. We're going to simplify that as well. And we are going to, we see that we have a division. There's nothing on the numerator to simplify, nothing in the denominator to simplify. So straight division with exponents. So 12 divided by 4 is going to give me 3. And x to the 5th divided by x to the 8th, I will subtract. 5 minus 8 is negative 3. So x to the negative 3rd power. And we will take y to the 7th divided by y to the 11th. So we subtract that and we get negative 4. And that's it for that part. So now we need to get rid of the negative exponents. So to get rid of them, we drop them to the bottom of the fraction and we make them a positive exponent. So the 3 stays on top, and the x to the negative third will drop to the bottom as a positive, and the y to the negative fourth will drop to the bottom as well and become positive. 29, simplify. Okay, in this problem, I don't see any multiplication or division. All I see is addition and subtraction. Okay, so I have this term minus that plus this whole thing, so there's nothing to distribute. Right, so it's just 2x squared plus 5x minus 12. So we will combine the terms that have the same base and exponent. So in this one, we're seeing that I have x squareds, and I have 5 of them, so it's 5x squareds plus 2 more x squareds. So altogether, I have 7x squareds. It's kind of hard to read. So 7x squareds. Okay, then I have negative 3x's and positive 5x's. So that gives me plus 2x. And then I have 18 plus negative 12, and that gives me 6. So plus 6. Now none of these terms have the same exponent, so this is x to the second power, x to the first power, and no x. So they are 3 separate terms. We leave them just like that. Okay, for number 30, we are going to simplify this as well. So we are going to take this minus here, and we're going to, that's like multiplying by negative 1, so we're going to distribute a negative 1 to each of the terms inside of this parentheses. So I'll rewrite the problem as 6x squared plus 5x minus 17. So the first part did not change, that first trinomial did not change. And then we have minus 2x squared, because we're going to distribute that negative to each piece. And then this is going to change to minus 7x. And this is going to change to plus 14. Okay, now we're going to combine the terms that look the same. So I will take 6x squareds and add them to a negative 2x squareds. So together that gives me 4x squared. And then we're going to combine the x to the first power. So we have positive 5 and negative 7. That's negative 2x. And then last we have negative 17 plus 14 would give us negative 3, or minus 3. Okay, 31. Simplify. So I see on top that I have 3 terms, and I cannot combine any of them because this is x to the fourth, x to the third, or x cubed, and x squared. So they have different base and exponent, or they have the same base of x, but a different exponent. So we cannot combine these 3 terms. On the bottom, I have 3x squared, and it's saying that we want to divide these 3 terms by this term. So we're going to follow the rules of the laws of exponents. So 15 divided by 3 gives me 5. And now we're going to divide the exponent, so x to the fourth divided by x squared. Remember, we subtract the exponent, so we get 5x to the second power. Then it's 21 divided by 3, so that's positive 7. And then x cubed divided by x squared. We're going to subtract those, so we're left with x to the first power. And we take the last term, negative 12x squared, and divide it by 3x squared, gives me negative 4. And then x squared divided by x squared would be 1, because once again, anything divided by itself is 1. And so negative 4 times 1 would be negative 4. And if we use the subtracting the exponents, we would see that the 2 on top, we subtract the 2 on the bottom, and that gives us x to the 0 power. And remember, we don't want a 0. We would change that to a 1. Okay, so that's going to become 1. So we get 4 times 1, or negative 4 times 1, which is still negative 4. So our simplified answer would be 5x squared plus 7x minus 4. Okay, for 32, same principle here. We are just dividing, so we divide the coefficients, or the big numbers, and then we're going to subtract the exponents. Okay, on the top, it's easy to see them. I have 4, 3, and 2. And on the bottom, even though we don't see a number, anything just written by itself would be to the first power. So this is 6x to the first power. So when we subtract them, we're going to take the 4 and subtract the 1 here. Okay, so 30 divided by 6 is 5. And then x to the 4th divided by x is x to the 3rd power. And in the second term, that middle term, negative 18x cubed, when we divide the coefficients, we get negative 3 and x to the 2nd power, because we have 3 minus the 1 on the bottom. And for the last term, it's positive 12 divided by 6, which gives us a positive 2. And x squared minus x to the 1st would be just an x. Okay, 33. What is the simplest form of 5x minus 2 times 5x plus 2? Okay, to simplify this, we are going to distribute this binomial to this binomial. And when I say distribute, I mean to multiply. So we're going to take these two terms and multiply it by these two terms. So I'm going to take 5x and distribute it to each one of the terms inside of the other parentheses. Okay. Then when I finish that, I will take the negative 2 and I will distribute it to each of the terms as well. So it's a binomial times a binomial. So there's 4 times I'm going to be multiplying. So 5x times the 5x. So 5 times 5 is 25. X times x is x squared. Okay, so that's what I get here. So 5x times 5x is 25x squared. And then 5x times 2. So 5 times 2 is 10. So plus 10. And I have 1x. So I'm just going to put x here. And then we're going to take this negative 2 and distribute it to each term. So negative 2 times 5 is negative 10x. And negative 2 times positive 2 is negative 4. Okay, I'm going to add the like terms. So when I go to add like terms, they have to have the same base and exponent. So I have 25x squareds, and I don't have any more x squareds anywhere. So that's all I have for that. Now for my x to the 1st power, I have positive 10 here and negative 10 here. And those are actually going to cancel each other out, because 10 plus a negative 10 is 0. And I have minus 4 at the end. Okay, 34. Same thing. We are going to distribute this 6x to each piece. So 6x times 6x. So 6 times 6 is 36. X times x. Following those rules, we're going to add those exponents. So 1 plus 1 is 2. So x to the 2nd power. 6x times 1 is plus 6x. And then we're going to take the negative 1 here and distribute it to each piece. So negative 6x. And negative 1 times 1 is minus 1. We will combine the like terms. So 6x and a negative 6x combined is 0 x's. So I'm left with 36x squared minus 1. 35. What is the simplest form of 3x plus 4? Now this one's a little bit different than what we were looking at before when we followed the rules of exponents, right? We had a single term inside of a parentheses raised to the second power. This is a little bit different because we have two terms instead of just one. So what this really means is that we're going to take 3x plus 4 and we're going to multiply it times itself. That's what squared means. It means take whatever that piece is or whatever value it is and multiply it times itself. So I'm going to write this out as 3x plus 4 times 3x plus 4. I will then follow the rules for distributing. So 3x times 3x is 9x squared. 3x times 4 is 12x. And then we're going to take this positive 4 and distribute it to each piece. So 4 times 3x is also 12x. And 4 times 4 is 16. I will then combine the like terms. So I have 12x plus another 12x here in the middle. So I end up with 9x squared plus 24x's plus 16. Okay, 36, same thing. What's the simplest form of 2x minus 7 squared? So once again, it's two terms inside the parentheses. So we can't just take everything to the second power. We have to take this whole thing raised to the second power. So we write them as 2x minus 7 times 2x minus 7. And we're going to distribute the terms. So the two terms from this first one to the two terms here. So 2x times 2x gives me 4x squared. 2x times negative 7 is minus 14x. Then negative 7 times 2x gives me another negative 14x. I'm just going to drop that down there. And then negative 7 times negative 7 is plus 49. Okay, when I combine the like terms, we get 4x squared minus 28x plus 49. 37. What is the product of x plus 3 and 5x minus 4? So product means to multiply, so I'm going to multiply this times this, and we're just going to distribute like we did on the other problems. So x times 5x, so 1 times 5 is 5, and then x times x is x squared, and then x times negative 4 is negative 4x's, and the positive 3 times each piece, so plus 15x, and 3 times negative 4 is negative 12. I'm then going to combine the negative 4x and the 15x, and I end up with 5x squared plus 11x minus 12. 38. 2x plus 3 and 3x, or what is the product of 2x plus 3 and 3x minus 2? We are going to distribute this binomial, so these two terms, times this binomial, or times those two terms. So 2x times 3x gives me 6x squared. 2x times negative 2 is minus 4x. 3 times 3x gives me 9x. And 3 times negative 2 is negative 6. I'll combine the like terms here, so negative 4x and 9x, and that leaves me with 6x squared plus 5x minus 6. 39 Given the equation, 3x plus 7y equals 14, what is the slope of the line that represents this equation? Or what will the slope of the line that represents this equation be? Okay, so we need to find the slope. And the slope is found when we use slope-intercept form, which is y equals mx plus b. So we need to rewrite this where the y is by itself. 3x plus 7y equals 14. We are going to move the x's. 7y equals negative 3x plus 14. Okay. And then we are going to divide everything by 7. And we end up with y equals negative 3/7 x plus 2. Okay? The slope is always the coefficient of x, or the number that's being multiplied by x. So here it happens to be a fraction, so our slope is negative 3/7. So we would write that as m equals negative 3/7, because m represents the slope. 40, given the equation 5x minus 2y equals 10, what will the slope of the line that represents this equation be? Same thing, we are going to write it down so we can change it into slope-intercept form. So we'll move the 5x. And we will divide everything by 2, or negative 2. And we're left with y equals positive 5/2 x minus 5. The slope is the coefficient of x, or the number in front of x. So we have 5/2, so the slope is 5/2. 41, identify the x and y intercepts for 3x minus 4y equals negative 12. Okay, this is a pretty easy problem to solve. All you have to do to find x and y intercepts, right? So we're looking for values of x and y when, like if we're looking for the x-intercept, the value of y will be 0. So this whole piece would be 0, because negative 4 times 0 would be 0. So all we're really doing is taking this number and dividing it by the number that's in front of x, or the coefficient of x. So to find the x-intercept, we end up writing 3x equals negative 12, because we've made y 0, we've made it nothing, we've gotten rid of it. So we divide by 3, and we get x equals negative 4. So, okay, so the x value was negative 4, and the y value was 0 in this problem for the x-intercept. Now for the y-intercept, we are going to this time make x 0, so 3 times 0 is 0. So in the ordered pair, the x is now going to be 0, and we're looking for a value for y. So when I write this problem now, it's going to be negative 4y equals negative 12, and we're just going to solve for y. So negative 4, divide by negative 4 on both sides, we get y equals 3. So for an x-intercept, the x has the value when y is 0. For the y-intercept, the y has the value when x is 0. So it's also called the cover-up method. You may have heard that, where if you're solving for the x-intercept, you cover up the y with your finger, and then you actually only see this part, 3x equals negative 12. Get the value of x, write it down. And we know that y was 0, so we write that down as well. Then when we try to find the y-intercept, we cover up the 3x with our finger, and we divide by the negative 4 to get the value of y. Biggest mistake I see is that students end up putting negative 4 with the 3 and making an ordered pair for that. but that's not what we're looking for. We're looking for two different points. We're looking for where does it cross the x-axis, that's why it has a 0, and where does it cross the y-axis, so that's why we have a 0 here as well. So they're two different points, the x-intercept and the y-intercept. 42, we're looking for the same thing. We're identifying the x and y intercepts. So we will use the cover-up method to find the x's. So 6 times 0 is 0, so it's like that's nothing, so we just cover it up. And we take 12 and we're going to divide it by that 2. So I end up with 2x equals 12, divide by 2, x equals 6. So for this ordered pair, it's 6, 0. The x was worth 6 when the y was worth nothing. And then we're going to do the opposite to find the y-intercept. We're going to substitute 0 in for x, so we're making it nothing, so 2 times 0 is 0. So we're only left with this piece. 6y equals 12, divide by 6, and y is equal to 2. So for the y-intercept, we're going to end up with 0, 2. So this was the x-intercept, this is your y-intercept. Okay, given the graphs below, what is the domain and range of each function? Okay, so we are going to look for the x and y values. So domain is x, range is y. So for the domain, we need to identify the x values. So we're only looking at these numbers on the x-axis. So this point would touch, or it's located when the x value is -4. So we're going to write -4, comma. This one is -1, comma, 3, and then 4. And we're going to put that in a little bracket to show that that's a set of numbers. That's all the brackets are for. It just says that it's a set. For the range, we're going to look at the y values. So we're only going to look at these numbers here on the y-axis. So this touches at 4, 1, -2, -3. And I write them in order from least to greatest. So -3, -2, 1, and 4. -3, -2, 1, and 4. And we're also going to put that in a bracket to show that that's a set. And this was a discrete graph, so it has individual points on the graph, so we can list all of the individual values of those points. On the second example over here, this line is made out of billions of points, so we can't list all of the points on this line. It's impossible. And we can't list all of the points here. Okay, so we're actually going to use a compound inequality on this one to describe the domain and the range. We can see that we have an open circle here. So out of all the points on this line and all the points on this line, we can use all of these values because it's a closed circle, and obviously if it's on the line, that's a good point. So we use all these points, but when we get to right here, that open circle says we don't want to use that as a value for the domain or the range. So in this domain, we're looking for the x value, and that would be all of the values here. So if I'm looking at the left-right movement of my picture, how far does it move this way, how far does it move this way, we can trace this up and see that the furthest part on the picture goes backwards 2 units. So I would write -2 for the least x value, right? And then if I'm looking this way now, we're looking at how far does my image or my picture or my line or whatever we're using, how far does it move to the right on the x-axis. So this point comes all the way up to 3. So we only have to go over 3 units to the right to get to the end of the line. So I write a 3 here. So for my domain, we're looking at all of the values between -2 and 3, right? So between here and here. It includes this value, but it does not include this value. Okay, so the way I would write that, it would be negative 2 is less than or equal to x for the domain, which is less than 3. Right? It's not equal to in this problem. For the range, we're going to look at values of y, so we're only going to use the numbers on the y-axis. So we want to see how far down does my picture stretch and how high does it stretch. So the lowest point in my picture would be right here at negative 3. So I guess I'll use the red pen here. So negative 3 is the lowest point. And the highest point on my graph happens to be where there's a closed circle. It doesn't matter if there's a circle or not. If it's in the picture, you have to include it. So this one happens to have a point, so great, no big deal. We have a 2 here. Okay, and then we put everything least to greatest. So the lowest value for the range is negative 3. And we can see that we have an open circle here, so that does not include that value. So we just use less than. And for range, we use the letter y. And our highest point was 2. And since that's not an open circle, it is equal to, so we less than or equal to 2. Now some students are still confused on which way these symbols go. Well, if you think about it as we're looking at these numbers, negative 2 is going to be less than 3, so I would have to use the less than symbol here if we're just comparing the numbers. And then here, we use the same symbol because negative 2 is still less than 3. And then same thing on the bottom one. Negative 3 is less than 2. Negative 3 is less than or equal to 2. And that's just kind of how you look at it. So if we always put everything least to greatest, our symbols are always going to represent that. So the negative 2 is the least in both of these. Okay. 44. The tables given are linear functions. Write an equation for each table and use it to find the missing values in the table. Okay, so you could do this a couple different ways. You could use the slope formula, which is y2 minus y1 over x2 minus x1, and you would just use 2 points in the graph to find that. In the table to find that. Or you can use stat edit on the calculator. So anytime you see a linear function and you see 2 points, whether it comes in a table, on a graph, or 2 sets of ordered pairs, you can always take those x, y values and put them into a table in stat edit. So on your calculator, you push the stat button, edit, that's the first option, and you're going to type in the ordered pairs. It doesn't matter which ones you use. You could use this one and this one, or you could use the first one and the last one, or just the last 2 or whatever. But you always have to have at least 2 pairs, one x, one y, that's a pair, and then another pair. So the table would match in the stat edit would match these 2. Okay, we can't use this one because we don't know what that value is. Okay, so we use 2 that we know. So I would type this in to stat edit, and then once I get those values in, we push the stat button again, and this time instead of editing the values, which just means putting them in, so we're changing the values, we're editing them. So instead of editing, now we want to calculate something with those values. So we push the arrow button over to calculate, and it gives us the option. It gives us a bunch of different options. Now the option we want is we want to pick the one that says linreg, so it's linear regression, and that would be option number 4. So we're going to either scroll down or use the arrow to push down to 4, or we're just going to push the number 4 to pick that. So statcalc 4. Now when we do that, it's going to give us, it's going to say y equals ax plus b. So it's going to look like this. Y equals ax plus b, and it's going to give us the value of a, and it's going to give us the value of b. And the values that they give me is a is equal to 6 and b is equal to -5. So now I can write my equation using the a and the b. So we get y equals 6x minus 5. And then it's just a simple, we can either substitute the value of x into this equation so we can get the y, or we can type this into y equals and then go into the table and then just go to where x is 24 and it will give you the missing value here. Just to keep it easy, we're going to do y equals 6 times the value of x, so 6 times 24 minus 5. Okay, so 6 times 24 is 144, so y equals 144 minus 5, and 144 minus 5 is 139. Okay, 45. The table given is a linear function. Write an equation for the table and use it to find the missing value in the table. Okay, same thing. We're going to go into stat edit, type in two ordered pairs, stat calc 4, stat calc 4, and then it will give us the value of the slope a and the value of the y-intercept b. Okay, so we have, stat edit. Type in the values from the table, stat calc option 4, and that ends up giving us y equals ax plus b when a is equal to -2 and b is equal to 14. So we get y equals -2x plus 14. Then we're going to take the value of x here and substitute it in here, and then we'll find the value of y. So y equals -2 times 6 plus 14, and we get y equals -12 plus 14, and -12 plus 14 is 2. So the value of y in this problem would be 2. Sketch a graph of y equals ax plus b if a is greater than 0 and b is also greater than 0. Okay, so we're going to sketch a graph of a line. So this tells me that I'm going to get a straight line because this is slope-intercept form, and that's what we use to graph lines. And it's giving us two pieces of information that we have to make sure that we use. So the value of a, or the slope, is going to be greater than 0. So I'm going to pick any number that I want, because it's just telling us to sketch a graph. I'm going to pick any number I want that is greater than 0. So I'm just going to pick 2. So y equals 2x, and then b also has to be greater than 0, so I'm going to pick 1 for this one, plus 1. So plus 1. So now I'm just going to graph it. I'm going to start at 1 on the graph. That's my y-intercept. And I'm going to follow the slope. It's up 2 and over 1. So we have a point here. And then I would work backwards. So down 2, back 1. And we can see the pattern as I move along. Okay. It is a line because it's equal to, so I will connect the points here. Okay. And of course your line will look better than this. Okay. And that's it for this problem. Number 47. Your test score is a function of the number of correct answers. Is a function of is another way to say depends on. Okay. So if you look at the way that this sentence is structured, you have your test score depends. Right? Test score depends. So the test score is your dependent variable. So test score. And what is it depending on? It depends on the number of correct answers. So the number of correct answers. Okay. So what would be a reasonable domain for this? It just depends. I mean, you can have some really small tests or you can have some fairly large tests. So, of course, a test would have to have more than one question for it to be a test. So, more than 0 questions. So, we're going to take 0, and we're saying that's, everything for the test has to be greater than that. So, domain is X, so we're going to use the letter X here. And the number of correct answers, I don't know, we could say we have a 100 question test. So you could get all of them right. So it could be equal to the 100 correct answers. And that's a reasonable test. I mean, you could have a test that's more, you could have a test that's less, but basically we're looking for something that is between 0 and some reasonable number for test questions. Another way that you could see the function thing written, and they may ask you what's the independent or dependent variable, and if we're using the same thing, we have score and number of correct answers. You could see it written in function notation, so it could say score is a function of the number of correct answers. So I'm just going to put C for correct, I guess. So S, the score, is a function of the number of correct answers. You may also see it in a table, right? And we know that y depends on x. So the y in this case is your dependent variable. So test score is dependent upon the number of correct answers, which is our independent variable. Okay, so you could see it any of different ways. It could be in sentence form, it could be in function notation, or it could be set up in a table. 48. If 4x minus 5y equals negative 12, what is the value of x if y equals negative 4? Okay, 2 ways to solve this. The quick and easy way would be to just substitute negative 4 in for y. So it says y is negative 4. So I could just take that negative 4 and put it in right there for y. So it'd be negative 5 times negative 4. And I'm going to do that real quick. So we have 4x minus 5 times negative 4 equals negative 12. Okay. 4x plus 20 is equal to negative 12. We're going to get x by itself. So 4x equals negative 32. Divide by 4. And we get x equals negative 8. So in our griddable over here, we need to fill in the negative. So you would write negative up top, and you would fill in the bubble for the negative symbol. And the number 8, I like to be consistent, so I always write mine over here, right justified. So I write all of my numbers as far as I can to the right. And you would have to fill in the bubble there as well. Now, the other way to do it is to change this equation into slope-intercept form. Right? So we have 4x minus 5y equals negative 12. And divide everything by negative 5. Okay, and I end up with y equals 4/5 x plus 12/5. Then I would take this equation, and I would take this equation, and I would type them into y equals, and then I would solve it like a system, right? I would look for the intersection point of these two lines, and I will find the x value that way. So I type them in to y equals, I do second trace 5, and when they both graph, I hit enter 3 times, and it gives me the intersection point. The intersection point would have been located at -8, -4. As an ordered pair, and it asked for the value of x, so I would give them the value of x from that ordered pair. 49 is just like the ones that we did in our math reviews for the last couple weeks. So it says the first 6 numbers in a pattern are shown below. We have 6 numbers, so we're just going to name them 1, 2, 3, 4, 5, and 6. It's in a pattern. So 1 through 6 are going to be the position or the inputs for the x value or the n value in this problem. And the outputs are the numbers on the bottom, so the y value, so 2/3, 2/5, and on. Okay, it says if this pattern continues, which expression can be used to find the nth number in the pattern? So all I'm doing is I'm saying, okay, I know that I have some sort of input here to the nth power, and what would that look like this way? Which expression could I use to find some unknown number way out here? We don't know, right? So all I'm going to do is I'm going to pick any of these values of x and substitute it in for n. Okay, so I'm going to pick this one here. Doesn't matter which one you pick, you would need to try them in all 4 of your answer choices. So I'm going to take that 4 and I'm just going to substitute it in for n. Okay, I'm going to substitute it in for each one of these. And when I do that, I need to find to find out which one of these matches this output. Okay, so 2 on top, and then I'm going to take that 4. 4 plus 2 is 6, so it's 2/6. For the second one, for B, it's 2 times 4. That gives me 8. 8 plus 1 is 9, so I get 2/9. And the next one is 4 times 2 is 8. 8 minus 1 is 7, so I end up with 2/7. And the last one is n squared plus 4 on the bottom, so that's 16 plus 2, which is 18, so it's 2/18. And now I need to find out which one of these matches the output when the n is 4, or when the number was 4. And it's 2/9, so it's this one here. And number 50. Given the graph below, which of the following is a true statement about f of x and g of x? So when I go to solve this, I want to make sure I check every answer choice and I write whether it is true or false. Okay, so for letter A, g of x, so line g of x, is steeper than f of x. Okay, this line is steeper. It goes up more as it goes over. So it's if we looked at the actual slope, we're starting here and we're going to go to here to calculate that slope. So it's up 1, 2, 3, 4, 5, 6, and over 2. So the slope on this for f of x was 6/2, which is equal to 3, so 3x. And the y-intercept, we'll go ahead and put that down, was 1, 2, 3, 4, -4. Okay, now for g of x, so that was this line. G of x, we're going to look at its slope. So we're going to take this point here, and we're going to this point here. So it's up 2 and over 2/5. So for g of x it's equal to 2/5 x, and the y-intercept is 2. So just looking at the lines themselves, right, this line is steeper than this line, and we can also see that with the slope here written in numerical form. So we have 3, and that is greater than 2/5, so this would be steeper than this one. So this is written backwards. This should say f of x is steeper than g of x. So this one is false. And for B, f of x has a positive slope. That's true. That's going up. It's a positive 3. And g of x has a negative slope. That is false. That is also going up as we move left to right. And we can see that the slope is positive here. So that is also false. And the y-intercept of g of x. So we're looking at the y-intercept right now. So we're looking at this point. It is saying that it is less than f of x. And that's not true either, because f of x, that is less than that point there. And if we're looking at the intercepts, it's saying that g of x, or 2, is less than -4. And that is not true. And the last one, the x-intercept of f of x. So here is the x-intercept right here, is greater than the x-intercept of g of x. So I find g of x, and the x-intercept is here. So it says the x-intercept of this line is greater than the x-intercept of this line, and that is true. The question said which statement is a true statement, so we're going to pick choice D.